Yeah, okay. That was this hand, not this hand. Oh. All right, so the most profound numeric relationship you'll ever know. That is a very big claim. So what do I really mean by that? As plainly as I can explain, this purely numeric relationship has a very strong potential to really change your perspective relating to some very big questions. Who we are and where do we come from? And, relating to questions like these, we're going to be entering kind of the realm of a heated debate. And this realm, of course, is going to be the debate between Darwinian evolution versus intelligent design. So with this video, what I'll be doing is I'm going to be showing you a series of observations, and I'm going to be using this purely numeric relationship as the cornerstone for my position, which, to be clear, is going to be congruent with an intelligent design paradigm. And really, the entire purpose of this is to expand that realm of thinking beyond that which is dictated by Darwinian evolution, really to kind of broaden our perspective and kind of give us a new vantage point with which we can pursue truths that current paradigm of thinking is insufficient for. And yeah, that's essentially what I hope to do with this video, to accomplish all that and to share it with as many people as possible. So to that end, of course, liking this video, leaving a comment, subscribing to my channel, those are all very good things. But I think sharing it's going to be the most important thing. So yeah, I guess that's it. So, I'm Brian Downing, and I'm about to take you down the rabbit hole. So, let's get to it. Okay, so ever since I was a kid, we're talking like freshman, middle school age, when any kind of age where I was in a chemistry class, right? And, in chemistry class, of course, you have the periodic table of elements. And so ever since I was a kid, I was looking at this thing. I couldn't help but feel that there was something going on with prime numbers, right? So for instance, like on the periodic table, on the far left side, you have this nice column of like 4 consecutive prime numbers. And then there's like elements such as gold and silver and copper. They all line up together. They all line up together with one another. These are all elemental metals that have been known since antiquity, and they're all primes. Very interesting. So yeah, I'm having these thoughts, and it's kind of always kind of been there, and it's not that it's been gnawing at me, but it's just kind of this lingering feeling ever since then that there's just something going on. So of course, fast forward about 20 years, and this is December of 2017, and I'm working a job that afforded me a lot of free time on my hands. I mean, a lot. Like, I had time to kill. Absolutely wonderful job, best job of my life. Anyway, and on this particular day in December, I was just kind of curious, for whatever reason, as to the total number of stable isotopes that each of the elements had. So these are going to be the elements from hydrogen all the way up to lead, which has the atomic number of 82. And so I kind of organized everything by element and then how many total stable isotopes each had. And the first thing I noticed, of course, was that all the even numbered elements had significantly more stable isotopes than the odd number ones. And so, I'm kind of looking at that, kind of thinking a little bit about it. And of course, I had this, that feeling that was always kind of lingering about the prime numbers. So of course, primes are predominantly all odd numbers. And so, discounting 2, that's basically all there. So I look amongst the odd numbered elements only. And I organized it into prime numbers and non-prime numbers. So really, I kind of made a flaw in my logic where I just had prime numbers, but then I included the number 1 with the composite odd numbers. And so looking at all those, I counted everything up, and I saw that both groups are actually basically equal in number. And in fact, it was amongst only the odd numbers, the primes ever so slightly outnumbered the composite numbers. And really what my first thought was that, well, that's kind of a bummer. There's nothing really distinguishing anything between the two groups. So I kind of put it down, kind of stared out the window. And then I thought to myself, you know, I thought prime numbers were way more uncommon than that. But of course, you know, since we've discounted all even numbers, and then basically, you know, more than half of all composite numbers happen to be even, you know, that's going to carry out that, I guess to call it a prime number dominance, for however limited or for however finite that is. It's going to carry out for a while, but eventually, of course, there will come to be this point where composite numbers catch up, overtake them, and then just composite numbers will be dominant forever. So I'm like, okay, that's cool. But then I got to thinking, you know, I wonder what that looks like, where it occurs, and what it looks like, basically. And so I counted everything up, and what I saw just absolutely struck me. So I think what the best thing to do here is actually just show you that process of counting everything up, and then you will get to see what I see. Are you ready? Okay, so here's the chart, really. So what we have here is we have all of our prime numbers up top, composite numbers on the bottom, and I marked the delineation, of course, to where they are equal for the very first time. But of course, this is not the end of the story here. I continued forth on the bottom part of the whiteboard here, continuing on the relationship to where they are equal for the very last time as well. And as you can see, as we're incrementally counting up, the composite odd numbers are absolutely going to dominate. They are increasing at a rather rapid pace relative to the primes, which are already lagging behind. And you can see really that this is the threshold where primes end their dominance and forever, counting up to infinity. They will just be in the minority population, really, of numbers. And yeah, so that's that. Now, what really struck me, well, there's two things, of course, that really struck me, but what really struck me was that when you compare this to the periodic table of elements, what you see, of course, is within this range here to where primes have dominated up to where they are equal for the very first time. Within this range, you have all naturally occurring elements relating to the periodic table. And then up to this period of debate, really, where they're more or less equal, up to the point where they're equal for the very last time, you've actually got all the synthesized elements as well. And what's really kind of striking about that is the way the periodic table is organized. That comes up exactly to the end of the 7th period, or at least the very last odd numbered element. So yeah, very striking. Now here's the thing. It's so striking, and yet I can't find it anywhere. And that's a very curious thing. So what's going on here that may be contrary to the stance of academia that they wouldn't want to present this? And so here's the very interesting thing here. You count up all these numbers here up to where they're equal for the very first time. You can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 pairs of numbers. And that's really, really kind of curious because we as humans have 23 pairs of chromosomes. So I think it's really interesting how there's this large constituency within academia that is so vigorously against this idea of intelligent design. And, I mean, it could ultimately possibly be impeding upon some potentially big fundamental truths here. But that is a topic for another time, of course. But, we can at least examine this thing about kind of like our more immediate timeline of development. So, of course, humans and chimpanzees are very closely related. We've got very strong evidence for that. I believe we share something on the order of about 98% of our DNA. And, so the preeminent, theory as to what's going on there is that, at some point in the distant past, chimpanzees, the ancestors of chimpanzees and humans, whatever common ancestor that may be, and perhaps that's not even too dissimilar from chimpanzees that we have today, but at some point there must have been some population that that became isolated or semi-isolated from the greater population of chimpanzees, or their ancestors, of course, and whether that be by a mountain range or a river or some kind of obstacle. I mean, there's a lot of possibility as to what that could be, but somehow you have this population that's isolated, and perhaps the environment they were in kind of eroded away. Chimpanzees, of course, are adapted to a jungle, and humans are adapted to more of a savanna-like environment. So, you can imagine that jungle environment that they were isolated in had to have eroded away in a slow enough fashion that this species continued to make these adaptations, a series of species really, continued to make these incremental adaptations. And, in such a manner that, these environmental changes had to have happened in such a manner that it was slow enough not to kill them outright as well. That seems kind of unlikely, although plausible, given that your model of random mutation and then natural selection is your working theory for these changes. Possibly. So yeah, but here's the thing. And let's even presume that Darwinian theory is allowed to act on its own, such that we can presume that Darwinian theory is in fact correct. But even if it is, what's to say that it be necessary that we have 23 pairs of chromosomes as humans, or really any other chromosome count for that matter? I mean, you would think that any species with our unique traits, which give us this ability to, look at our world, think about it, and ask these big questions, and to understand these big questions. You would think that any species with that kind of ability would have any sort of random chromosome count, but we don't. We have exactly the right kind of chromosome count to be representative of this numeric relationship. And that's just kind of a striking coincidence to me. A very staggering kind of coincidence, I think. And, it does kind of beg the question as to, what's really going on, really. And here's the other thing that's really staggering here as well, is these differences between humans and chimpanzees the staggering thing is in addition to the things that make us different, which will give us these abilities, such as the greater cognition, the more articulate dexterity, which allows us the use of tools and in a much more ergonomic fashion. Our complex vocalization ability. All these things which are necessary to allow us to create such a large, sprawling society, to open up these avenues of thought and science and mathematics and all this stuff. What comes along with them is a chromosome change. So you see the other great apes, they all have 24 pairs of chromosomes, and presumably with millions of years of evolution in between them, right? So, and here we are, human beings, new kids on the block. Here we are with all these abilities to investigate these avenues with the exact right kind of chromosome count. That's a very, very curious situation, I think. And I think the coincidence is so staggering that you've got really no other possibility than that those changes occurred as a consequence of some kind of intelligence acting upon these changes. So yeah, I mean, very potentially profound prospect there. So yeah, so I think I'll just leave that there for now. I think I've presented a nice introduction to my stance or my worldview here. Again, this one observation, you start asking questions about it, and it's really, really curious. It's a really curious thing, I think. So I will definitely be making an effort to come out with more videos, of course. Examine more nooks and crannies related to this numeric relationship. But yeah, I mean, it is my contention that as a species, we are no accident. And I think that's really something special. So again, I guess I will conclude that there. And again, if I can enlist your help, liking this video, subscribing to my channel, leaving a comment, those are all very good things. But again, yeah, sharing it's going to be so important. And again, share this with people you trust, I think, would be good. Don't just share it willy-nilly necessarily, unless you feel comfortable doing that. But share this with your chemistry teacher, your nuclear physics professor, your pastor even. These have potentially religious implications. So share this with your drinking buddy you like to have debates with, you like to have arguments with. If you have that kind of relationship with that people and you enjoy that, you revel in it, do it. So yeah. So I'm Brian Downing, and yeah, this has been a trip. Thanks for sticking along.